Why is the night sky silent when it should be full of worlds? What if the answer everyone repeats, that something is coming, is the one thing the evidence rules out? And whatever silences a civilization, is it ahead of us or behind? This is the story of a lunch at Los Alamos, one unproven assumption, and 6,000 silent worlds. In the summer of 1950, 4 physicists walked to lunch at Los Alamos. It was an ordinary day. They had been laughing about a cartoon in a magazine, flying saucers, little green men, the kind of thing that was in the air that year. The talk drifted, the way lunch talk does, to other subjects. Plates were set down. And then, somewhere in the middle of the meal, apropos of nothing, one of them looked up and asked a question that landed flat on the table. Where is everybody? The man who asked it was Enrico Fermi, one of the great physicists of the century, the man who built the first nuclear reactor. And that single offhand question, asked between bites, would go on to become the most famous question in the search for life beyond Earth. Here is what almost everyone believes about that moment. They believe Fermi was issuing a warning, that he looked at the size of the galaxy, did the math, and realized with a chill that we are alone in a place that should be crowded. They believe he was asking why no one is out there, and that the silence frightened him. It didn't happen that way. Fermi wasn't even asking whether aliens exist. By the most careful account we have from a man who was at that table, he was asking something narrower and stranger, whether crossing the distances between stars is even possible, or worth the effort, or whether anyone lasts long enough to try. He never published a word on the subject. He died 4 years later, and the frightening argument the world would eventually pin to his name, the cold, hard case that the silence means we are alone, was not written by Fermi at all. It was written by someone else, 21 years after Fermi was dead. So, before we ask whether something out there is waiting to end us, there is a smaller question to ask first, and it is the question this whole story turns on. Who decided the silence was frightening, and were they right? 21 years after that lunch, a man named Michael Hart sat down at a desk and wrote the argument everyone would blame on Fermi. Hart was an astrophysicist, and in 1975 he published a short, blunt paper. It opened with a statement he called simply Fact A. There are no intelligent beings from outer space on Earth now. That was the foundation. From it, he built a chain of reasoning so clean it feels like a trap closing. If intelligent life existed anywhere else in the galaxy, Hart argued, then given enough time, it would have spread. It would have built ships, or sent machines, or seeded other worlds. It would have crossed the galaxy and arrived here. They would have colonized. But they are not here. Therefore, they do not exist. That is the argument. That is the thing people have spent 50 years calling the Fermi paradox. And almost nothing about that name is right. Fermi didn't make this argument. He was dead before it was written. The chain of reasoning is Hart's. Even the phrase Fermi paradox came later still, first printed 2 years after Hart's paper by yet a third person who pinned Fermi's name to Hart's idea. The most famous puzzle in the search for alien life is named after a man who didn't pose it, describing an argument he never made. It's the first crack. Because once you know the scary story has been told this carelessly, once you know that even the basic credit is wrong, there is something much bigger to check. A leading historian of the field has argued that the whole thing isn't even a paradox. A paradox is a contradiction, two things that can't both be true. But life might exist somewhere else, and no one is here on Earth do not contradict each other. They sit together perfectly well. There is only a contradiction if you add one more thing. You have to assume that life, once it gets started anywhere, will inevitably spread until it fills the galaxy and becomes impossible to miss. That assumption is the whole engine. Pull it out, and Hart's trap springs open and catches nothing. Everything frightening about the silence, every version of the fear that something is out there, or was out there, or is coming, grows from that one plank. That life expands, that it makes itself seen. Hart treated it as obvious. Most people still do. But it is not a fact, it is an assumption. And the entire story from here is the story of that one assumption being built up, hardened, attacked, and finally tested against the only evidence that can decide it. 5 years after Hart, a mathematician decided the one weak point in the argument could be removed entirely. In 1980, Frank Tipler sat down to fix the weakest part of Hart's argument. Because there was a weak part, and everyone knew it. The obvious objection to "they would have colonized the galaxy" is that crossing a galaxy is monstrously hard. The distances are almost beyond imagining. Sending living beings across them would take generations, fortunes, lifetimes piled on lifetimes. Maybe no one ever bothers. Maybe it is simply too expensive, and that is why the sky is quiet. Tipler's job was to take that escape away. And the way he did it is one of the most unsettling ideas in the whole subject. You don't send people, Tipler said. You send a machine. But not just any machine. A machine that can build a copy of itself. Imagine sending one such probe to a nearby star. It arrives, finds raw material, rock, metal, ice, and uses it to build 2 copies of itself. Those 2 travel onward to 2 more stars, and each of them builds 2 more. 2 becomes 4, 4 becomes 8, 8 becomes 16. The growth is exponential. You do not need a galactic empire with a budget. You need one civilization, somewhere, willing to launch a single self-copying machine, and then patience. And here is the part that lands like a stone. Tipler ran the math on how long that would take. Starting from one machine, by his reckoning, the copies would reach every corner of the galaxy in a few 100 million years. That sounds enormous. It is not. The galaxy is more than 10 billion years old. A few 100 million years against 10 billion is a fraction of an afternoon. On the clock of the cosmos, a single civilization with one self-replicating probe would fill the entire galaxy in a blink. Tipler's paper had a title to match. He called it, flatly, "Extraterrestrial intelligent beings do not exist." Not probably, not may not, do not exist. The argument now felt airtight. They are not here. They could have flooded the galaxy cheaply and quickly with one machine and time. They didn't. So there is no one. Notice what that whole structure is standing on. The premise underneath all of this, underneath Hart, underneath Tipler, underneath every frightening version of the silence, is a single claim. That at least one civilization, somewhere, across all of cosmic history, would inevitably choose to expand, and would do it in a way we could see. Tipler's machines make that expansion cheap, but they do not make it certain. The whole tower rests on the idea that somebody, eventually, builds the machine and sends it. That somebody wants the galaxy. That expansion is what life does. State it plainly, and it stops sounding like a law of nature and starts sounding like what it is: a guess about the behavior of minds we have never met. Tipler's blunt title reads like proven certainty. It rests entirely on an assumption about what aliens would want. Pull that assumption, and the certainty evaporates. The argument was now as strong as it would ever get, if its one assumption held. 3 years after Tipler hardened it, Carl Sagan sat down to take it apart. In 1983, Carl Sagan and a colleague named William Newman wrote the first serious rebuttal. And Sagan, of all people, was the one who said it out loud. Sagan was the great optimist of the search for life, the man who believed the galaxy might be teeming. And his argument was not that Hart and Tipler had made a mistake in the math. It was that they had made a mistake about minds. Think about what Tipler's machine actually does, Sagan said. It lands on a world, tears it apart for raw material, builds copies of itself, and sends them on to do the same to other worlds. A swarm of self-copying probes does not politely visit a galaxy, it consumes it. It eats stars and planets for parts, endlessly, forever. And Sagan's point was simple. A civilization wise enough and old enough to cross the stars might look at that machine and refuse to build it. Not because they couldn't, because they wouldn't. Because turning the galaxy into raw material for an endless replicating swarm is the kind of thing a mature civilization decides not to do. And if that is true, the empty sky proves nothing at all. The absence of galaxy-eating machines is not evidence that no one is out there. It might just be evidence that no one chose to unleash the machines. Absence of probes is not absence of minds. Now, the moment Sagan opened that door, a whole family of explanations crowded in behind it. Each of these is a way to say, they're out there, but silent. And there is one test that cuts through all of them at once. Here is the test. Every one of these explanations requires not one civilization to behave a certain way, but all of them, everywhere, forever. And a single one that breaks ranks brings the whole thing down. Take the idea that they are deliberately leaving us alone, that we are a kind of wilderness preserve, a zoo they have agreed not to disturb. For that to keep the skies silent, every civilization that has ever existed has to make the same choice and hold to it across millions of years, with no exceptions and no defectors. Or the idea that advanced civilizations grow quiet and turn inward, losing interest in the stars. All of them? Forever? Or the darkest version, that the galaxy is a dark forest where everyone hides because anyone who speaks gets destroyed by a predator. That last one is genuinely gripping, and it deserves to be named for what it is. It comes from a novel published in 2008. It is fiction. Its nearest serious cousin in the scientific literature ended not with "the forest is full of hunters," but with a shrug, "we cannot say." And it fails the same test as the rest. Hiding only works if everyone hides, and one civilization that decides to expand, or simply to broadcast, breaks the silence for the whole galaxy. That is the blade, and we will use it again. Any explanation that needs every mind in the galaxy to make the same choice forever is broken by the first one that doesn't. And there is a quieter version of the same crack that needs no alien psychology at all. In 1998, a physicist named Geoffrey Landis pointed out that even if civilizations do expand, they may not fill the galaxy evenly. Settlement could spread the way a fire spreads through patchy grass, leaping some gaps, stalling at others, leaving permanent islands of emptiness. We might simply be sitting in one of the voids. No conspiracy of motives required, just the geometry of how things spread. It doesn't explain a totally silent sky by itself, but it chips away, again, at the idea that expansion means we should obviously see them. So, the single assumption that the whole fear was built on, that life inevitably spreads and makes itself seen, has now been shown to be exactly that, an assumption. And it was the field's most famous optimist who turned it over. The clearest living voice of that very premise, the one Sagan was attacking, belongs to a physicist most people will recognize.
The physicist is Brian Cox, and he has spent more time explaining this question to ordinary people than almost anyone alive. When he sets out the case, he sets it out plainly, and it is worth hearing in his terms, because it is the premise in its most reasonable dress. The galaxy is old, Cox says, older than 10 billion years. It holds hundreds of billions of stars and far more planets than that. There has been time, enormous time, for life to arise and spread. If anyone out there had wanted to make themselves known, they have had more than long enough to do it. And yet we look, and we see nothing. That is the premise stated by someone who has clearly thought about it. Old galaxy, countless worlds, deep time. So where is everyone? Cox also voices the escape, the same door Sagan opened. Maybe, he says, they are so advanced that they are already here in some form, and we simply do not recognize them. Maybe what we are calling silence is just our own failure to perceive. It is a real possibility, and it deserves to be weighed rather than waved away. So weigh it, with the same blade from before. For they are here but unrecognizable. To explain the whole silent sky, it has to be true of every advanced civilization, everywhere, across all of time. Every single one choosing or happening to be invisible to us. The moment one of them is detectable, the silence is broken. It is the same flaw as the zoo and the dark forest. It needs a universal monoculture of behavior, and a single exception undoes it. So we raise it, we weigh it, and we set it down. And here is the striking thing about Cox. Having walked all the way through the premise and its escape, his own guess lands somewhere most people don't expect. He has said, in his own words, that the average number of civilizations in a typical galaxy may be less than one. Less than one. His reasoning is the timeline of our own planet. It took the best part of 4 billion years here, he points out, just to get from a single living cell to a creature that could build a radio. The galaxy, he suspects, may be full of microbes and empty of minds. Now, Cox is careful, and we should be too. He calls all of this guesswork. All these thoughts are guesses, is how he puts it. He is not announcing an answer. He is one thoughtful voice weighing the same premise everyone in this story has wrestled with and leaning tentatively toward rarity. Hold that lightly. It is a thread, not a verdict. The thing that could actually decide it has not arrived yet. Because around the same time Cox was thinking this through, the question had already been given its sharpest possible shape by someone else, an economist named Hanson, who in the late 1990s did the single most useful thing anyone has done with the whole problem. He gave it a name, and he gave it a rule.
Hanson took the silence that Hart and Tipler and Sagan had all been arguing about, and he reframed it. Somewhere on the long road from dead matter to a galaxy-spanning civilization, he said, there must be at least one step that almost nothing gets past. One barrier. One wall in the road that stops nearly everything. He called it the Great Filter. And then he wrote down the rule that this entire story has been moving toward. The rule that, applied to the evidence, decides everything. In his own words, the easier it was for life to evolve to our stage, the bleaker our future chances probably are. Sit with that for a second, because it is the machine at the heart of all of this. Our hope for the future, Hanson wrote, is directly pitted against our hope that the past was easy. Here is what he meant. The filter is somewhere on that road. It has to be. Something is keeping the galaxy quiet. So the only question that matters is where. And there are two places it can be. If the hard step is behind us, if the wall in the road was something we have already improbably climbed over, like the very origin of life, or the leap to complex cells, then the silence is good news. It means the rare and difficult thing already happened, and it was us. The future is open. But if the hard step is ahead of us, if the wall is still in the road somewhere up ahead, and civilizations reliably arrive at it and reliably fail, then the silence is the worst news there is. It means everyone before us hit the wall and died, and we are walking toward it now.
That is the fork, and the most important thing about Hanson is what he refused to do. He refused to say which side we are on. He insisted that the location of the filter is precisely the thing we do not know, and that what should move our guess one way or the other is evidence about how hard the past actually was. He set the fork, he would not resolve it. The rest of this story is the search for the evidence that can. For the next 25 years, one man's version of the dark side of that fork would become the most quoted sentence in the entire field. In 2008, the philosopher Nick Bostrom wrote an essay that gave the fear its peak, and he wrote it not with a shout, but with a kind of dread calm. He was thinking about the rovers we send to Mars, the probes we send to the moons of Jupiter, all of them quietly searching for signs of life. And Bostrom wrote that he hoped they would find nothing, dead rock, lifeless sand, nothing alive anywhere we look. To understand why a careful man would hope the universe is empty, you have to follow his logic to its sharpest edge. Here is the line that made the essay famous. Finding simple alien life, Bostrom wrote, would be by far the worst news ever printed on a newspaper cover. The worst news ever. Why? Run it through Hanson's rule. The filter is somewhere on the road. Suppose we go to Mars and find life, independent life, life that started on its own. What would that tell us? It would tell us that the very first step, getting life going at all, is easy. It happens twice in one solar system. And if that early step is easy, then it is probably not the filter. The wall in the road is not back there at the beginning, which means it is more likely to be somewhere else, somewhere ahead. Every early candidate for the filter that we rule out pushes the probability forward toward the part of the road we have not yet walked. Find life, and you have ruled out the comforting answer. That is Bostrom's nightmare, and stated cleanly, it is genuinely frightening. This is the strongest the fear ever gets. For a moment, follow it where it leads. Every microbe we ever find on a dead world becomes one more reason to think the wall is still ahead and that we are walking toward it. So set the first weight against it, not to dismiss it, but to size it correctly. Bostrom's claim is conditional, and the condition matters enormously. It only bites if the alien life arose independently, a genuine second beginning. But Mars and Earth have been trading rock for billions of years. Meteorites cross between them. So if we found life on Mars and it turned out to share our biochemistry, the same machinery, the same chemistry of inheritance, that would not be a second start at all. It would just be Earth life that hitched a ride. It would tell us nothing about whether life is easy. The nightmare requires a true second genesis, and that is a much narrower and much rarer thing than just finding something alive. And Bostrom himself was careful about this. He never said the filter is ahead. He said that finding life would shift the probability toward it. A shift, not a sentence. The fear is real. It is also narrower than the way it usually gets repeated, which is exactly why what comes next matters, because the whole question now turns on a single thing. How hard was the past, really? 10 years after Bostrom, 3 researchers in Oxford asked a quieter question: whether the silence had ever really been a paradox at all. In 2018, 3 researchers at Oxford sat down to rerun the numbers on the whole question, and what they found was that the paradox may have been, in part, a mistake in arithmetic. For decades, people had estimated how many civilizations the galaxy should hold by taking their best guess for each of the unknowns. The odds life gets started, the odds it becomes intelligent, how long it lasts, and multiplying them together. And the answers usually came out large, millions of civilizations, which made the silence feel like a screaming contradiction. So many expected, not one found. But the Oxford team pointed out that those unknowns are not single numbers. They are enormous ranges, spanning many orders of magnitude, and we genuinely do not know where the truth sits inside them. And when you carry that honest uncertainty through the math properly, instead of multiplying single best guesses, something surprising falls out. We are alone stops being a contradiction. It becomes an ordinary result, one of the perfectly expected outcomes. The cleanest way to feel why is a coin flip. So imagine one. Suppose a single coin decides the fate of the galaxy. Heads, it fills with 10 billion civilizations. Tails, it holds exactly 0. Now, what is the average outcome? 5 billion. But look at that number. 5 billion describes neither real world. The real galaxy is either crowded or empty. It is never the average. So you can have a huge expected number, 5 billion, sitting right alongside a 50-50 chance that the true answer is none. The big number and the empty sky were never in conflict. We had been staring at the average and calling it a paradox. That is the most freeing idea in the whole subject. The silence does not need a monster to explain it. It does not need a filter ahead, or a dark forest, or a conspiracy of zoos. Alone can simply be the ordinary roll of the dice. But this is not proof that we are alone. It cannot be. The whole result leans on one bespoke number: how likely it is that life ever gets started at all. And that is the single thing we understand least in all of science. We have exactly one example of life beginning, our own, and from one example, you cannot read the odds. 2 years later, a careful critic showed just how much weight that one number carries. Model the odds of life starting in one reasonable way, and the chance we are alone in the galaxy comes out around even. Model that same unknown a little differently, just as defensibly, and the chance we are alone collapses to something far smaller. The whole conclusion swings on the parameter we know the least about. So here is the honest shape of it. The Oxford work is the strongest case available that the silence was never a paradox. It is also not airtight, and saying so is the entire point. The disciplined claim is not "science has proven we are alone." It never could be. The disciplined claim is narrower and truer. Alone is an ordinary outcome, not a contradiction. The thumb is starting to settle, but the counterweight is still openly on the scale. Ordinary is not the same as proven. To know which side of us the filter is really on, you need a clock. And it turns out there is exactly one we can read.
So here is the clock. There is exactly one record anywhere that can tell us whether the early steps were hard, and it is written into the planet under our feet. The history of life on Earth. How long each transition actually took, laid down in the rock, layer by layer. That timeline is the only evidence we have that can point to where the filter sits. The idea of reading it that way is decades old. Back in 1983, a physicist named Brandon Carter looked at that timeline and made a careful argument. The path from a dead planet to a thinking species probably contains only a small number of genuinely hard steps, maybe one, maybe two. Not a long list of difficulties, a short list of near impossibilities. And ever since, the fight has been over how to read the delays in the record. What we know is the shape of the timeline. Life appeared on Earth fairly early. Then, for most of the planet's history, for billions of years, it stayed simple. Single cells and not much more. Complex life, the kind that builds bodies and brains, arrived shockingly late and arrived almost at the end of the time the planet had available. The sun is slowly heating, Earth has a window of habitability, and complex life showed up near the closing edge of it. That much is in the rock. What we do not know is what those long delays mean, and this is the live, unresolved fight at the center of the whole subject. There are two ways to read the same timeline, and they point in opposite directions. So we are going to walk into each one, slowly, one at a time, and live inside it for a moment. Here is the first reading. Suppose the long delays mean exactly what they look like, that the hard steps really were freak accidents, fantastically unlikely, the kind of thing that almost never happens. If that is true, then you would expect a planet to spend most of its life stuck, waiting, with nothing advancing for ages, because the next step is just that improbable. And you would expect the jump to complexity to take so long that it barely fits in the window a world has before its star turns hostile, which is exactly what we see on Earth. A team of researchers modeled precisely this in 2021. They worked out how long you would expect to wait for intelligence to appear if the steps really are that improbable. And their answer was sobering. The expected wait runs longer, much longer, than the window most planets get. On most worlds, the star would die, or the planet would turn hostile, long before the slow climb to intelligence ever finished. Which means intelligent life is rare, vanishingly rare. And the filter, on this reading, is behind us. We are one of the freak successes, and that is precisely why the sky is silent. That is a clean, frightening, behind us story, but it has a weakness. It reads the universal odds off a single example, our own planet. We are reasoning about how likely the steps are from the one place we know they happened. And one data point is a thin thread to hang a galaxy on. Now here is the second reading. Suppose the long delays are not improbability at all. Suppose instead that Earth simply could not host each next step until the planet itself was ready, until the air had enough oxygen, until the chemistry, the climate, the whole planetary system had cleared the way. On this view, life was not waiting around for a freak accident, it was waiting for permission, and it took each step roughly as soon as the planet allowed it. The long delays are not the odds being against life, they are the planet slowly clearing its throat. In 2024, a team of scientists made exactly this case. They argued that the standard hard step story ignores something enormous, and their own words are worth hearing. The model, they wrote, famously ignores perhaps the prime determinant of macroevolutionary timescales on Earth, the Earth system itself. If they are right, the timeline tells us almost nothing about whether life is rare. The delays were never about improbability, they were about a planet getting ready. And if that is true, the thumb on behind us lifts. But here is the part the popular version of this paper always leaves out, and the authors themselves did not. They were careful to say what they were not claiming. They did not claim to have proven the rare life model wrong. They said only that they had built a real, testable alternative to it. And they did not claim that creatures like us were inevitable, only that the timing, by itself, does not prove we were unlikely. So neither reading is settled. Both are live. Anyone who tells you this is closed is selling something. A 2021 team says the timeline points to rarity. A 2024 team says the timeline can't prove rarity. But look closely at even the challenge, the strongest case against rarity. It does not argue that life is common. It argues, more modestly, that the timeline alone cannot prove life is rare. That is a real and important point. It is not the same as evidence that the galaxy is full, and set that single piece of evidence back into the whole chain we have walked. No escape route for the silence survives the blade. None of them can keep an entire galaxy quiet without a universal monoculture broken by a single defector. Worlds are common. Confirmed detections anywhere after decades of looking number 0. And our own history took nearly 4 billion years and almost the whole window the planet had just to make us. Put all of that together and the timing evidence leans toward early steps that were genuinely hard. The careful reading is rarity, not doom, a lean, never a proof. So the chain ends where it has to. Step back from the people and the papers and look at the sky as it actually stands. This is the sky as it actually stands today. As of now, we have confirmed 6,000 worlds beyond our own, with more than 8,000 more waiting to be confirmed. And rocky worlds in the comfortable zone around their stars, the zone where water could be liquid, appear to be reasonably common. Not every star, not a guaranteed Earth in every system, but common enough that the room out there is real. The galaxy is not short on places. And not one of those worlds has ever sent us a single word. We have looked. The most sensitive searches have swept the nearby stars, listening for any transmitter far stronger than anything humanity has ever built. And they have heard nothing. Those searches have covered only the loudest possible signals in a tiny slice of the sky for a tiny slice of time. It is a real constraint. It is also a weak one. We have barely begun to listen. The silence is not proof of absence, it is just silence so far. There was one moment, recently, when it looked like the silence might break. A planet 100 and some light years away, for a few months in 2025, seemed to show a chemical in its air that, on Earth, is made by living things. For a little while, it looked like the planet might be breathing. And then a careful joint reanalysis went back through the data and found that the signal was not really there. The sky stayed quiet. So here is where the evidence leaves us. Common worlds, total silence. And a history that, read carefully, looks hard rather than easy. Put those together with Hanson's rule that hard early steps mean a safer future, and the most disciplined reading, the one the best evidence leans toward, is the quiet one.
The filter that explains the silence most likely sits behind us. The unlikely thing already happened. And as far as we can tell, it was us. Hold that as a lien, not a verdict carved in stone. We are reading the odds of everything off the single example we happen to be. In a universe this size, certainty is the one thing we are never going to get. But sit with where that direction leads, because it is not the place you were brought here to fear. The story you were promised was dread, that something out there is coming for us, that the filter is ahead and our turn is next. The honest answer is stranger than that, and lonelier. Being first is not safety, it is a weight. The thing to sit with is not that something is coming, it is that there may be no one, that the quiet you are looking up into is not a warning, but simply the quiet of a room with no one else in it yet. The silence was never the thing to fear. Being the only voice in it might be.